name's Matthew Berry. I'm lead operations engineer on DC-8. I went to school, got my EE degree, Bachelor of Science at New Mexico State University. The DC-8 is part of the Airborne Science program. The importance of airborne science is it gives experimenters a tool to where they can real-time make upgrades to their equipment, a place to test it out and see if that's what they really want to do in the satellite in orbit. It's like a test bed for new equipment. You get a lot of different experiments. Each campaign has its own unique item that it's searching for. CO2 and O2 emissions within the atmosphere, biofuel emissions testing. Some weather type stuff like lightning strikes. We'll go into hurricanes. You get to go everywhere. Houston, you go to Kansas, you go to Maine, and then you get to go to Chile, maybe Germany. It's not really limited. Wherever the science wants to go. The experiments that are on, so we have the ATM, which is Airborne Topographic Mapper, ATM Topographic Mapper Sigma. As an OE, you're basically a big coordinator. You got to coordinate with all the science teams, the upper management levels. You have to coordinate between the mechanics, you have to coordinate between the avionics techs, you have to coordinate between all the back shops for fabrication.
Paladine, small parts that we can do in-house.
Housekeeping's working on right now. So pretty much almost done.
You're also the technical representative for your ground crews. You got to be able to talk to all the different shops and know what they need and what information you got to get to them so you can help solve all the problems.
Just need some seats in here, we'll be good. Hey Tex, did you guys already do the connector for the iridium?
Yeah, here's the antenna cables are right there. Here's the power and Ethernet, so it's already here.
Yeah, so we'll probably have to take that off.
I like getting my hands dirty. I like being there with the crew. That's the best part. We deal with a lot of outside experimenters and everything, so they're physical people going on our aircraft that are bringing non-aircraft airworthy instruments on. We'll make sure that all their components, they have a correct layout on all the racks that are on the aircraft to make sure that it's structurally sound and can withstand all the loads. On the DC-8, for one example, there's lasers. And there's a lot of rules that you gotta follow with lasers for a safe eye distance that somebody could look at it with some binoculars or a camera lens. Each laser has to go through a process, get evaluated, and we get that distance. Along with that, you have to coordinate it with the FAA.
Morning, Karen.
So a typical non-flight day, you're kind of just making sure you have all your paperwork in order. So making sure the aircraft maintenance items are taken care of, working with the ground crew to see what issues have come up and how we're gonna work to address them. Our favorite thing as ops engineer now is working in NAMUS, keeping that up to date with all the maintenance items and making sure that everything stays on track. And if I'm working something in the back shop, I'm kind of coordinating with them for getting the parts fabricated and making sure they have all the materials. Do a lot of pre-planning for upcoming missions. For flight day, for me, it gets really busy. If I'm not flying, I'm kind of there early, right when the crew gets there, and just start prepping it, doing the pre-flight items. You're finalizing all the weight and balance numbers. Just running around making sure everything is good to go there and the paperwork signed off appropriately. And then usually on the day that I fly, I'm usually just getting myself ready with whatever the flight plan is and what the experimenters are wanting to do that day.
So science, we got Stuart Wu.
Here.
Mike Rodriguez.
Here.
We got Sven.
You go to the pre-flight briefing, you give the briefing to the scientists, everything, as a mission directors, their safety brief and everything, just kind of reiterate. Get a feel for what they're trying to do and what their main goals are for that mission. Sit on the aircraft and control the mission and interface with all the pilots and the scientists at the same time.
All right, everybody, we're getting ready for the taxi, so make sure you got all your seatbelts on and your belted and ready for taxi and takeoff.
Tonight's mission has us flying out to over the Indianapolis area, and they'll be taking the laser measurements for CO2 and O2. Today my role is mission director. And what you do is, for this campaign, we're monitoring the TCAS system up there because we have lasers on board, so we have to watch out for planes underneath. Normally you're communicating with the scientists on what changes they need to do. So if we're, like for this mission, kind of worried about clouds and stuff like that, if we're close to a cloud area, the scientists will kind of redirect us and say, hey, let's move over a little bit to the east or the west or north-south. A lot of it is just doing the coordination and re-coordination of flight routes and making sure that the scientists are following the rules that we set up and that they're getting all the data that they need. You don't realize how fun it is to be flying 500 feet off the ground until you're doing it. And especially in this big tanker as DC-8, because you kind of see all the smaller aircraft, and you think this big DC-8 that kind of scares everybody in the neighborhood.
Okay, mission O2 is off.
All right, thank you. Ready to close your shutter, right?
Yes, go ahead and close the CO2 shutter.
Thank you.
FA 17 cross ether at or above 5,000. Runway 2500.
Either at or above 5,000 foot.
All right, everybody, the seatbelt sign is now officially on. Be landing here shortly. CO2 sounder, how's your flight? LAS, how's your flight? After it lands, you kind of come back just to see if there's any aircrew discrepancies, go through the post-flight debrief, and just see what they bring up so you can work any issues if there are any issues, and help make the decision whether it's going to be a go, no-go for the next day. I truly love my job. Like, it's never a dull moment. It's always going to be something different every day. I really love what I do.